Hi and welcome to the 6th section of this course, continuing the 2D adventure. In the previous section we started work on a 2D adventure game. On reaching this point we've now created a controllable character that can navigate a level using physics and collision detection as well as gravity. This section completes the 2D project by adding the remaining features. This section will demonstrate the following topics: moving obstacles and features such as an elevator platform, gun turrets to attack the player, an NPC with a quest system. Now we'll see the first video of section 6, moving platforms. Now let's refine the adventure further by adding a moving element to the existing scene, specifically a moving platform object. The platform should move up and then down again on a loop, ping-ponging between the extremes. The player will be able to jump onto the platform to hitch a ride, and the object will be constructed as a prefab, allowing it to be reused across scenes. To start, select the platform texture in the project panel, making sure that it's specified as a sprite, 2D and UI, texture type in the object inspector. The sprite mode should be set to single. Drag and drop the platform texture to the scene and set its scale to 0.7, 0.5, 1. Next, the platform should be a solid object, the kind of thing with which the player can collide. Remember, the player should be able to stand on the platform. Consequently, a collider must be added. In this case, a box collider 2D is appropriate. To add this, select the platform object in the scene and navigate to Component, Physics 2D, Box Collider 2D from the menu. After the collider has been added to the platform, you may need to adjust its properties from the object inspector, specifically its offset and size fields to make the collider match the size of the platform sprites closely. Then, finally, test the platform by entering the play mode and standing the player character on the platform. By doing so, the player should not fall through the platform. The platform so far is static and motionless, and it should move up and down repeatedly. To fix this, we could create a predefined animation sequence using the animation editor via the Window Animation menu option. However, instead we'll use a script file. Frequently, when making animations, you'll often need to reach decisions about which option is best, C# animations or baked animations. Typically, a script should be chosen when an animation should be simple and must apply to many objects and vary for each. This script file, pingpongmotion.cs, should be created and attached to the platform. Now we'll see the code and the comments. The pingpongmotion class is responsible for moving a game object back and forth from an original starting point. The awake function uses the origPos variable to record the starting position of the game object. The update function relies on the mathf pingpong function to transition a value smoothly between a minimum and maximum. This function fluctuates a value between minimum and maximum repeatedly and continuously over time, allowing you to move objects linearly. For more information, see the Unity Online documentation at this site. The completed code should be attached to the platform object in the scene and can be reused easily for any other object that should move up and down regularly, or left and right. Nice! We've successfully learned about moving platforms. In the next one, we'll learn to create the other scenes.